Good morning, everybody. I'd like to thank you all for joining us here today. My name is Jim Edwards, and we're here today to discuss the launch of one of the most significant, one of the most necessary efforts ever undertaken by the scientific biodiversity community. We are here to announce the official launch of the Encyclopedia of Life. The Encyclopedia is an unprecedented effort, unprecedented global effort, to document all 1.8 million named species of animals, plants, and other forms of life on Earth. Once completed, the encyclopedia will provide scientists, students, and all citizens with multimedia access to all known living species, even those that have just been discovered. I almost cannot put into words how exciting this development is for scientists, citizens around the world, and me in particular. Many of us have dreamed and wished for such a development for many years. And finally, we have the commitment, the resources, and the technology to make this dream, this wish, a reality. This morning, we will hear from Dr. E.O. Wilson of Harvard University and Dr. Jonathan Fanton of the John D. and Catherine T. MacArthur Foundation. One of the world's foremost scientists and environmentalists, E.O. Wilson is one of the godfathers of the Encyclopedia of Life. Professor Emeritus at Harvard University, Dr. Wilson publicly wished for the establishment of the Encyclopedia of Life when he was honored at the March 2007 Technology Environment Design Conference. Ed?
Thank you very much, Jim. This certainly has been a dream come true, and it has an undeniable great future now activated. In 1758, Carl Linnaeus, a great Swedish naturalist, introduced the binomial system of classification, which is essentially the one used today and is highly effective. Yet, 250 years later, we still have discovered as few as 10% of the actual species on Earth. 1.8 named and diagnosed, and easily it could be 10 times that, and quite possibly more. Most kinds of flowering plants and birds, for example, have been discovered, but our knowledge of the vast array of insects, of fungi, and of bacteria and other microorganisms is shockingly incomplete. For example, about 60,000 species of moles, mushrooms, and other kinds of fungi are known to science, but the true number has been estimated by experts, shot in the dark, but as best they can do is to exceed 1.5 million. The number of known species of nematode roundworms, the most abundant animals on Earth, 4 out of every 5 animals on Earth is a nematode roundworm, is about 16,000 species, and the number easily could be in the hundreds of thousands or millions. On the order of 10,000 species of bacteria have been now diagnosed and given a name to which that shall allow our immediate access to information, perhaps 10,000. But 5,000 to 6,000 species of bacteria are to be found in a single handful, a gram of fertile garden soil, almost all unknown to science. And some 4 million species have recently been estimated to exist in a single ton of soil, also all unknown. As for our knowledge of them goes, they might as well be on the planet Mars. Each of these and millions of other species are exquisitely well adapted to the environments in which they live and where many of them have existed for hundreds of thousands to millions of years, living interlocked with one another in webs of interaction which we have scarcely begun to explore as scientists. Yet they are a large part of the foundations of Earth's ecosystems. Our lives depend upon this largely unknown living world that we now propose to begin to explore and to understand more fully. Humanity exists, in other words, on a little-known planet. What knowledge we have, and there's a lot, about the 1.8 million, is nevertheless scattered all through very technical literature. It is hard to obtain. It is usually available and even known about to a limited number of experts. In dealing with the living world, we are flying blind, or mostly blind. When we try to diagnose the health of an ecosystem, such as a lake or a forest, for example, in order to save and stabilize it, we're in the position of a doctor trying to diagnose and treat a patient knowing only 10% of the organs, and also of the doctor being rather out of touch, not in connection, knowing what other doctors know. Now, at last, new advances in technology, including genomics, that is, reading the genetic code of each species. That can be done, for example, now for the million base pairs of a bacterium in under 4 hours. High-resolution digital photography and internet publication allow us now to combine and organize and access quickly what is known of the living world to this point, and thereby speed the exploration of the unknown part of the living world by as much as 10 times. I have recently done this myself, following an 18-year study and 5,000 drawings at my own hand of the largest ant genus in the world, adding 20% or 20% of all the known ants of the Western Hemisphere. And I could have done it, if I started now, I think I could do it in 6 months. Well, that's an idea of how it is. We need to organize the information into this electronic encyclopedia and make it, and we propose to do this, immediately accessible as an open source everywhere in the world. This dream, which is today being brought to reality, is called the Encyclopedia of Life. It represents the convergence of scientists, and quite a few of them, principally working in museums and herbaria and other centers of major collections of species diversity, and planners in the large libraries that contain the totality of already existing information on biological diversity, all of which will be useful to us in the new enterprise, and experts on information technology. These have combined now to create the reality. There are compelling reasons, in closing, to build such an encyclopedia with an indefinitely expansible page for each species in turn, containing everything known about that species, from genome to organismic traits to its position in the ecosystem, its kinds of interactions with other species. New phenomena as this develops, new phenomena, and new connections among phenomena of biology will come to light. Only with such encyclopedic knowledge can biology as a whole mature as a science and acquire predictive power, species by species, ecosystem by ecosystem. The encyclopedia is thus going to be our macroscope, to be comparable to the microscope used mostly in biology to this point, a powerful instrument for basic and applied science. Finally, the encyclopedia will serve the interest of humanity in immediate and practical ways. The discovery of wild plant species adaptable for agriculture, new genes for the enhancement of crop productivity using the small number of species on which humanity depends, and new classes of pharmaceuticals. All will be accelerated by the information as this is accumulated and added to. The outbreak of disease agents and harmful plant and animal invasives will be better anticipated. Never again, with the knowledge of adequate extent that we hope to acquire in a matter of a few years, need we overlook so many golden opportunities in the living world around us, or be so often surprised by the sudden appearance of destructive aliens that spring from that little-known world. And we're very grateful, those of us who've been involved in the planning of this and the conception of it, for the support now provided by the MacArthur and Sloan Foundations that make this initiative possible and practicable. And we will be very grateful for the favorable attention of the many scientists and others around the world as this project takes form. Thank you.
Thank you very much, Ed. It's clear that your passion for biodiversity and your commitment to this project are two of the major reasons why we're all able to be here today. Thank you very much. I'd now like to turn the program over to Jonathan Fanton of the MacArthur Foundation. The Encyclopedia's steering committee and I are able to stand here today because of the commitments and trust we have received from the MacArthur Foundation and the Alfred P. Sloan Foundation. In pledging its support to the creation of the Encyclopedia, the MacArthur Foundation has provided $10 million to help jumpstart the initiative. Dr. Fanton?
Good morning. Well, it's always an honor to follow Ed Wilson on a podium and be inspired by the power of his creative mind and the eloquence of his voice. Ed has been a champion and spokesman for a big idea whose time has come. Just a little over a year ago, he suggested to us an endeavor that could advance science and deepen our understanding of the world around us, as you've heard, the Encyclopedia of Life. And this is the actual letter, copy of it, that Ed wrote to me proposing the idea. Simple, clear, powerful, inspiring, and here we are. Today, I'm proud to announce that the MacArthur Foundation is taking the lead in providing a total commitment of $20 million, 10 is the first installment, to create the encyclopedia. We're joined by the Sloan Foundation and by 6 founding partners, and in all, our partnership will provide $50 million, a little over $50 million, to get the project started. 5 great institutions and a leading international scientific information consortium have come together in partnership to launch the EOL. They are the Smithsonian, Harvard, the Field Museum of Chicago, the Marine Biological Laboratory at Woods Hole, the Missouri Botanical Garden, and the Biodiversity Heritage Library, which is a group of 10 leading museums that is digitizing the relevant scientific literature. We hope soon to be joined by the Atlas of Living Australia as one of our early partners, and over time, we expect the ELO will be joined by other museums and scientific institutions from Asia, Latin America, Africa, in a truly global endeavor. Before going further, I want to acknowledge a modest man sitting here, Jesse Ausubel of the Rockefeller University and the Sloan Foundation, who's taken the lead in assembling the people and the institutions which is turning Ed's dream into reality. This wouldn't have happened without Jesse. The Encyclopedia of Life can raise our sights and expand our view of life on Earth. And as Ed said, just as a microscope reveals and helps us better understand the small and the particular, the EOL can serve as a macroscope, allowing us to discern patterns previously unseen illuminating relationships, identifying gaps in our knowledge, and suggesting opportunities for new avenues of inquiry. It can help track biodiversity as climate change and human activities put species under pressure, and the EOL can add great value to the work of the scientist, the student, the conservationist, the policymaker, and not to forget the passionate amateur. The idea of the Encyclopedia of Life has been advanced before, but now the time is right, and we all know in life timing is everything. Recent advances in information technology and software applications have opened new possibilities, and now a useful, dynamic online guide to information about Earth's approximately 1.8 million known species can happen, and it can happen within a relatively short period of time. An important number of existing databases, such as the International Plant Name Index, the Barcode of Life, and the Ocean Biogeographic Information System, have already made significant advances and can be linked to the EOL. In addition to its inherent scientific value, the EOL has clear utility for conservation, interdisciplinary research, and information sharing, especially in the developing nations where access to science is very limited. And I think it's fair to say this could be a revolution for science in the developing world, and that's part of MacArthur's attraction to this. We have a conservation and sustainable development program focusing on biodiversity preservation that works worldwide in places like Madagascar, the Albertine Rift, Vietnam, Papua New Guinea, Latin America, Peru, lots of places. And many, many of those countries, this will be a new way of doing science. The EOL will be based on principles of accuracy with quality control provided by a credible review process, of accessibility with free access to the information it provides, and inclusion with participation invited from scientific organizations and individuals worldwide. Accuracy, accessibility, and inclusion. For the EOL to reach its full dimension, it must be a global endeavor, a resource of knowledge that is created by all, maintained by all, and with benefit to all. And so in addition to the founding partners who have constituted a steering committee for the EOL, there will be an institutional council with broad global participation of other institutions being formed to advise the operation of the EOL, its scientific applications, quality control, and outreach. There will also be a distinguished advisory board of individuals who will be an important resource. And the content of the EOL will depend on contributions from thousands of individuals and institutions throughout the world. So what you see here is a beginning, a launch, a first moment. When we gather again sometime next year, when it all goes live, we expect there to be a very broad representation from all over the world. We are enormously lucky to have attracted a distinguished scientist to head the EOL, to be the executive director of the Secretariat, which is based at the Smithsonian. Dr. James Edwards comes to us from heading the Global Biodiversity Information Facility, and that project has given him a deep understanding of the challenges ahead and of the people and of the institutions all over the world that are going to come together to make this a reality. And so it's now my great pleasure to invite Jim back to the podium and to tell you more about how this is all going to unfold. Thank you.
Thanks a lot, Jonathan. Professor Wilson and Dr. Fanton have eloquently laid out the vision, the funding, and the large-scale goals for the Encyclopedia of Life. And it's my role now to explain how the job will be accomplished and when the encyclopedia will be operational. The Encyclopedia of Life will be implemented through 5 mutually interdependent core tasks or components. The first one, of course, is creating the species pages themselves. Unlike many other species encyclopedias, the species pages for the sites will largely be constructed by aggregating content from existing resources rather than sitting down and writing new text. The information then will be authenticated by the scientific community so that users can be assured that the information is authoritative. Early on, much of the information in the Encyclopedia of Life will derive from current species catalogs. The encyclopedia has instituted collaborative arrangements with 3 essential resources in this area. One of them is the Catalog of Life Partnership, which contains authenticated information on the scientific names of more than 1 million species and expects to finish the job of all 1.8 million within the next 3 years. The second is the Tree of Life web project, which maintains an excellent family tree showing how all the species of the world fit together. And the third is FishBase, which maintains one of the most complete databases for a single group of organisms on Earth. The encyclopedia will share content and software tools interoperably with these projects and with many others, with clear credit given to the sources of all information. In addition, as Dr. Fenton has noted, the Atlas of Living Australia, which is preparing a species catalog for the Australian content, is poised to become a core participant in the encyclopedia. And international attention has also been raised by the announcement from the G8 environment ministers meeting in Potsdam, Germany in March, that they wish to foster a global species information system in which the Encyclopedia of Life will be the central element. Overseeing the development and the authentication of the species pages falls largely to the Encyclopedia of Life Secretariat, which, as Jonathan has mentioned, will be led by me and located at the Smithsonian Institution in the National Museum of Natural History. To pull together the disparate information needed in order to construct the draft species pages, new software and standards for sharing data are being developed in an open source, open access environment. In addition, one of the innovative features of the Encyclopedia of Life is that it is intended to act as an entry point, or as multiple entry points, I should say, for all kinds of information about species. And to foster this, individual scientists or organizations will be able to register their data sets with the encyclopedia so that other users can discover the data and use them. Developing and maintaining the software resources is the job of the informatics component, which is led by the Marine Biological Laboratory in Woods Hole. In fact, the encyclopedia's software team will build what we are calling taxonomic intelligence, a special form of artificial intelligence, into the encyclopedia. Connected to each species page will be articles, monographs, and other literature about those species. Access to this biodiversity literature is being provided by the Biodiversity Heritage Library Project, a consortium of 10 of the world's largest natural history libraries. Through a collaboration with the Internet Archive, the BHL will scan and digitize tens of millions of pages of print media, all intelligently linked to the species information. The scanning and digitization of the biodiversity literature provides unparalleled depth to the encyclopedia and, as mentioned earlier, will really help people in developing countries get access to this information that now is largely unavailable to them. In fact, the Biodiversity Heritage Library has already scanned in excess of 1.25 million pages. The fourth component is education and outreach, jointly chaired by Harvard University and the Smithsonian Institution. This group will prepare innovative tools for educators and students ranging from new curricula for teachers to resources for citizen scientists. Moreover, interested citizens will be able to feed information back into the encyclopedia. For example, a school district might undertake a bio-blitz, identifying species in its locale and submitting that information to the encyclopedia. Or a gardener might provide precise data about growth and propagation of plants in a particular place. This two-way process will make the Encyclopedia of Life a true partnership and a living resource for all kinds of users. Finally, the Biodiversity Synthesis Center, the fifth component, housed at the Field Museum of Natural History, will provide an environment for the scientific community to invent new ways to use the species images and the species pages and new tools for accessing them. We like to say that the Synthesis Center will be one of the major tools for developing the macroscope mentioned earlier that will allow us to look across all of the species pages and integrate information. Together, these five components will create an outstanding, multidimensional encyclopedia that will be heavily used, ever evolving, ever improving. Of course, we have milestones that we've set up and that we must meet, or that we aim to meet at least. The Encyclopedia of Life is envisioned as a 10-year project. The first species sites will begin appearing in 2008, early 2008, and our goal is to have approximately 50,000 species sites available by the end of 2008, and nearly 1 million sites up and running by the end of the first 5-year period. Achieving such ambitious goals will take unprecedented effort and collaboration, but we're confident that the community interest, the informatics tools, and the initial funding are now in place to accomplish this. We were astounded, or at least I was astounded, by the intense excitement shown by attendees at the March 2000 Technology, Entertainment, Design Conference, where Professor Wilson received one of this year's TED Prizes, and where he wished for the creation of the Encyclopedia of Life. The idea of gathering together species-level information and making it freely available over the internet is something that people from all walks of life understand, support, get excited about. And we are privileged to have the job of building upon this goodwill in order to implement the encyclopedia. As I mentioned at the beginning, the Encyclopedia of Life will be one of the most significant developments in the life sciences. Just as the biotechnology industry has been built upon the existence of large genomic sequence databases, the Encyclopedia of Life will have an equally catalytic effect on comparative biology, ecology, and related fields. By harnessing the commitment, the hard work of scientists across the world, the encyclopedia will serve as a truly global resource for information regarding life on this planet. It will provide society at large a tool unequaled in scope and convenience for policymakers, for educators, for scientists, for the general public. We now have a couple videos to show you. The first one is a videotaped statement from Minister Miliband in the United Kingdom, and I'll play it right now.
Good morning. I'm very sorry I can't be with you in person today, but I did want to send a message to say that the full weight of the British government is behind this very exciting initiative. The Encyclopedia of Life is going to be a global resource. What could be more appropriate for a world that is more and more connected, where issues of climate change, issues of biodiversity join us together across natural and national boundaries. I believe that the drive of major scientific institutions, from the UK, the Royal Botanic Gardens at Kew and the Natural History Museum, joining with scientific institutions in the United States and around the world, really is a unique endeavour. Unique endeavour, wholly appropriate to our times. The Department for Environment, Food and Rural Affairs, my department in the UK, has twin goals: the protection of our natural environment and the battle against climate change. They go together, but they have a distinctive place, each of their own. For my part, the Encyclopedia of Life has got a major contribution to make. It can help raise awareness, it can deepen our understanding, and it can share expertise. At a time when the relationship between human beings and the natural world is more and more under discussion, and in some places more and more under threat, I believe that the Encyclopedia of Life has got a major contribution to make. To Edward Wilson, I say, thank you very, very much for your vision, your drive, and your passion. I hope you believe that today, and for the future, it's been worth it. Thank you very much indeed.
David Miliband is the Minister of State, Secretary of State for the Department of Environment, Food and Rural Areas in the UK. We now have a short video prepared by one of the attendees at the TED conference, a company named Avenue A Razorfish, working with the informatics team of the Encyclopedia of Life. They've prepared some visionary, we hope exciting materials that indicate how one might be able to put the species pages together and utilize them. So can we please see that video? inspires me every time I see it. Fantastic pictures, nice production, et cetera. I really want to thank the Avenue A people and the informatics team at the Marine Biological Laboratory for putting it together. You have in your materials for today a DVD upon which you will have this video, so you can watch it to your heart's content. We're now to the point in the program where we'll be happy to take your questions. Before we do that, I'd like to introduce the members of the steering committee for the Encyclopedia of Life who are here today. Jonathan Fanton is the president of the Field Museum of Natural History. Sorry.
I'd like to be.
Too many Johns. John McCarter is the president of the Field Museum of Natural History. Screwed that up. Christian Sabert is the acting secretary for the Smithsonian Institution. Gary Borisi is the director of the Marine Biological Laboratory. Jesse Ausubel is at the Sloan Foundation and Rockefeller University and is the chair of the steering committee. Joanne Daly is someone we hope will soon join us. She is the leader of the Atlas of Living Australia and is at the Council for Scientific and Industrial Relations in Australia. Chuck Miller is here today from the Missouri Botanical Garden, the latest entity to join. Graham Higley from the Natural History Museum in London is the chair of the Biodiversity Heritage Library Consortium. And Jim Hankin is here representing Harvard University. So with that over, we'll now be pleased to take any questions that any of you might have. Everybody was wowed by the video.
Hi, I just had a quick question about sustainability. So the sum of money to start you up is impressive, but if this is going to be sustained forever, how will it be paid for in the longer term, so for sort of 50 years or that kind of time frame?
Could I ask Jonathan to give us a perspective on that, and perhaps Jesse also to do so?
Well, the opening amount is in excess of $50 million. Estimates range between 70 and 100 to do the 1.8 million. I believe by the time the first 5 years and 50 million have been invested and expended, and you see a lot more than what you just saw, there'll be no difficulty in encouraging both more gifts from private foundations and perhaps individuals as well as governments. You heard a powerful statement, the full weight of the British government behind this. I don't have any doubt that the rest of the funds will come. Speaking after 10 years, that's beyond my power of prediction, but I have no doubt that we'll complete the job on time.
We're creating a utility. Jim Edwards in his remarks mentioned what geneticists have done with GenBank. And we hope for comparative biology, for macrobiology, the Encyclopedia of Life will be similarly useful and valued. And so I think for the long term, there should be revenue to support this kind of utility, which will be enormously valuable to a range of users. We certainly will be looking carefully at a range of models for both revenues and expenses, and we're mindful that if we create something that's very expensive to maintain, it will be much harder to maintain. So we're very glad to Eric Mulder from the Wikipedia Foundation is with us here today, and we're very mindful of low-cost models for creating and sustaining utilities on the web. Obviously, we can't do things like that for every 2 minutes that will be of the encyclopedia.
Other questions?
Yeah, I'm Tim Beardsley with Bioscience. A couple of weeks ago, I was in this building for the announcement of the launch of the Earth portal. And I wondered if you could comment on possible synergies, similarities, differences between your project and that also ambitious undertaking.
I guess I get to answer that one. I think that there are lots of possibilities for synergies. We're following different models in developing what we're doing versus the Earth portal. The Earth portal is largely to be written by individuals, more like a standard kind of encyclopedia. But clearly, linking up biodiversity data and earth science data is a strong collaboration that can lead to being able to predict climate change, to deal with questions of evolutionary biology due to drifting continents and changes in where species live. So interoperability between the materials that we're developing in the Encyclopedia of Life and the Earth portal, as well as lots of other resources, is one of the things we really will need to strive to do so. We have not to date had any specific discussions with them, but it's on our long list of to-do things. Jesse also has something I'd like to add.
I think we have the simpler task in a sense, in that we are about species. So we have an organizing principle which will keep us on track. So we have these. We're dedicated to the 1.8 million species. The Earth Portal is another wonderful project which encompasses many things in earth sciences and environmental sciences, many categories of subjects, many kinds of subjects. But I think we hope to be, and we hope the Earth Portal would recognize the Encyclopedia of Life as the go-to place on species. So I think that's really the core.
As I mentioned, we expect to have about 50,000 species pages up and running and available for people to use by the middle or third quarter or so of 2008. One of the biggest problems we're going to have, I believe, is managing expectations. People all want to see their favorite animal, plant, microorganismal group available immediately. We're not going to be able to do it immediately. And so maintaining the interest of people while we're able to pull in the resources and the information that will cover their animal group or plant group or whatever is something we're going to need to manage. So 50,000 pages or so toward the end of next year, 1 million by the end of the 5-year period, 1.8 million in another 3 to 5 years after that. We believe that that is achievable in that the current English version Wikipedia has about 1.7 million entries. So we're talking about, at least in terms of the individual species sites, something of about the same magnitude as the current Wikipedia. We think it's achievable. Well, if there are no further questions, then I'd like to thank you all very much for coming here today. I hope that some of our excitement about this project has infected you. And we look forward to interacting with many of you in this room as we actually begin to develop the Encyclopedia of Life. Thanks very much.